In this tutorial, we're going to talk about factoring perfect cubes. And before we start learning how to actually do the factoring, we need to make sure that we know what our perfect cubes are. So I'm going to get some numbers listed. I'm just going to go up to 10. Okay, so I'm going to go ahead and cube all of my numbers here. So I'm going to do 1 cubed, which is just 1, and 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed, which is 64, and I'm going to finish this up for us real quick. And there we go. So you are going to want to start being able to recognize when you have a perfect cube, and when you are able to do that, these problems become so much easier. So let's go ahead. I'm going to give you an example of a perfect cube, and we're going to see exactly how to factor it. Okay, so here are our rules. If we have a sum of 2 cubes, we write it like it says up here. And what you need to do first, before you do anything else, is you need to be able to actually write your initial perfect cube as its cube roots. Notice that here, where it says x cubed, that's not what this x here represents. This x represents the number that is going to be cubed to get that original number. The same thing goes for the y. Now, the best way I can think of to show you this is through an example, so let me get that set up. Okay, so here's our first example. We have 27x cubed plus 8. And I know that this is a sum of perfect cubes because I know that 27 and 8 are both perfect cubes. So here's what we're going to do. We need to write this so that it is something cubed plus something cubed. And whatever those somethings are going to be that x and y respectively. And I'm going to use blue instead of purple because I don't have purple up here in my color box. So let's think of what we could cube to get 27x cubed. First of all, to get the 27, I know that that's going to be a 3. That's going to be 3 cubed, which is 27. And then I have to do x as well, because x cubed is x cubed. So that's the first part there. My y is just going to be a number. It's not going to have an x in it. So what cubed is 8? And the answer there is 2. So now I have my x and my y, and now I'm going to follow this pattern. So it looks like it has a plus sign here. I'm going to leave the x's and y's open so that I can mess with them as I need to. So those are the signs that I need. And now I'm going to go in and show where I need the x. So this is an x, this is x squared, this should be an x, and then this should be my y, this should be times y, and then this should be y squared. So now I'm just going to fill in everything where they need to go. So just take your time when you're doing your setups. So the x term was 3x, so he's going to be written right here. And 3x squared, that's this part right here, I'm squaring the x, that would be 9x squared, because 3 squared is 9 and x squared is x squared. And now I'm going to bring down my 3x right here, and I'm going to put a multiplication sign right there because it's going to be multiplied by something. And now I'm going to bring in my y, which is 2. So I'm going to write plus 2 and times 2, and then 2 squared is 4. So the last part is just to simplify. So the 3x plus 2 doesn't need any simplification, as it's already simplified already. And I'm going to bring down the 9x squared. And now 3x times 2 is negative 6x, and then plus 4. And that is my answer, just like this. So now let's take a look at an example where it's a difference of 2 cubes. Okay, so let's say this is my example. I have 343x cubed y to the 6th minus 729. Now, first of all, before we do anything else, we have to write this as a difference of 2 numbers or values that are being cubed. So the first term is this 343 x cubed y to the 6. So let's work with the coefficient first. And I know that the cube root of 343 is 7. Okay. So now let's take a look at the x term. The cube root of x cubed is just a plain old x. Now the y part is a little trickier because we have to make sure that you know your power rules really well. But remember that if it's a power to a power, that's when you multiply the exponents together, right? So what would the exponent have to be here on my y multiplied by 3 to give me 6? And if you said 2, you would be correct. So inside here would have to be a y squared. Okay, that one was hard. Let's move on to the next one. So now 729. The cube root of 729 is 9. And now that I have my perfect square or my perfect cube set up, I can go ahead and plug it into my formula. So I'm going to have, let's see, a minus sign there, and then a plus, and then a plus, and a close parentheses. Okay, so I'm going to follow this formula on the bottom, and it's going to be x minus y. So that means I have 7xy squared, and then minus 9. So those are my perfect cubes. Now for this part here, I need to do x squared. So 7 squared is 49. And I'm going to erase that plus sign because I think I need more room. And then x squared is just x squared. And then y squared squared is y to the 4th. Okay. It's taking up quite a bit of room there. So now I have to do the x times y part here, which is, there's the x, there's the y. Let's multiply them together. So that's going to be 7xy squared times 9. So 7 times 9 is 63. So my middle term here, I'm going to erase that plus sign, I'm running out of room, is going to be 63xy squared. And then my last term is just the y part squared, which is 9. So 9 squared is 81. And it doesn't really, there's anything else to simplify here. I did that pretty much as I went. So this would be my final answer. And that's going to conclude this tutorial.